Hey guys, welcome to our next lesson on finance. Today we're moving into chapter 8 and our goal is to link an understanding of recurrence relations and compound interest to solve amortisation problems. So that's a big word and we're going to talk about all of that today. Our first subheading for today is reducing balance loans. Now I don't want you to write all of this down. We're just going to have a chat about it. The biggest loan most people take out is to buy a home. That can be a huge amount of money, guys, often over $800,000. And these loans are taken over really long periods of time, up to 35 years, sometimes longer, sometimes less. But here's what's interesting, and here's what I want us to write down. Home loans are not charged at a flat rate of interest. The interest on these loans is what we call reducible, which means that the interest is calculated on the amount owing on the loan at the time rather than on the amount initially borrowed. This is called a reducing balance loan. So I want you to write that down, what's in yellow there. In reducing balance loans, we usually charge the interest monthly. So what that means is, guys, if you think about this, and I'm not reading this now, if you take out an amount of money P and then you make a payment on that minus your payment X dollars, all right, the new amount, which is less than the original, is the amount that interest is paid on. So if you keep making a regular repayment, the interest that is compounding is always going to be slightly less. And this is what I want you to write down next. This means that the amount borrowed is paid off in the early stages of the loan compared to the end. That is, the rate at which the loan is paid off increases as the loan progresses. All right? That's because we are decreasing the total amount of the loan every time we make a little payment X. All right? Now, it is possible to have an interest-only loan, but we're not going to talk about those today. Okay. Let's get stuck into some examples. So, if we think back to our recurrence relationships from earlier, we had AN plus 1 equals RAN, but a relationship can be written to model a reducing balance loan. And this is what it looks like. We say AN plus 1 equals RAN, sure, minus capital R, where that capital R is the monthly repayment. We still need to make sure we state that A naught equals A at the very beginning. And our other variables are exactly the same. So R is the same as lesson 1 last week. So is A naught, so is AN. Those definitions have not changed. So using this recurrence relation idea, all right, we're now going to link that in with our compound interest ideas to do example 8 together. So Jeffrey borrows, I'll scroll up so you can still see that formula. There we go. Jeffrey borrows $3,500 at a rate of 6.5% per annum, interest compounded monthly. Let's underline those key things. He is to pay this back monthly with installments of $711.42. Write a recurrence relation to describe this situation. Okay. Well, the general format for that is AN plus 1 equals RAN minus R. So that's the new thing here. It is important, though, that we figure out what little r is, just like we did earlier. R equals 1 plus, now we have to write that as a decimal, remember, 0.065 is R as a decimal, and we have to divide that by the number of compounds per year. So in this case, this is compounded monthly. So over 12, which means we can write R as the decimal 1.0054. Now, it's always nice to round R to 4 decimal places. Okay, let's go back over to the left now. So in other words, we can write AN plus 1 equals 1.0054 AN minus, and this capital R here is simply this monthly installment, 711.42, where A naught equals 3,500. So that's how we answer part A to that question. Not forgetting to write that little comma there as well. Looking now at part B, we're actually asked to use this relation. Using your calculator to determine use your calculator to determine the number of monthly repayments needed to pay off this loan. Well, guys, what we're going to do is we're going to use the iterative method. All right, so we're going to punch in 3,500 to our calculator, hit equals. But this time, rather than just hitting multiply by 1.0054, you're then going to have to make sure you hit minus 711.42. Okay? Then, when you hit equals, your first term, A1, is going to be equal to 2807.48. So that number there considers we've added the interest and also minused off the repayment. So hit equals 4 more times until you get how much money is needed to pay off the loan. So I've just written a few there. So if we keep going with hitting equals, we get this moving forward. Let's keep going, constantly pressing equals, guys, until we're getting below 0 or $0. And we find that we get a negative number here. All right. So this point here, we see that we have a negative sign. This means that the loan is paid off after the 5th repayment. It will take 5 months to pay off the loan. Now, it does mean though, you notice that we have a little bit of a deficit. That just means that the final loan repayment is going to be a tiny bit less than that amount. And that's good. That's fine. We can make our final repayment a little bit less than the $711. That's not a problem. So that's how we answer that. Now, guys, what we've just done here is basically model a process of paying off a loan with regular repayments. So our next subheading is paying off a reducing balance loan using a table. And what we just modeled is the process of amortisation, which is the process of paying off a loan with regular payments. We can do this as a step-by-step process by looking at a table. And that's going to be our next example. So let's get on to that. All right, this is crazy, so bear with me. I just want you to consider that this example here is in your textbook, and it's basically just for you to see what the table ends up looking like with all the working out. So just before we considered a payment of $711.42, an interest rate of this per month, that's R, remember. It's to do with the previous month's balance and so on. And you also notice that these numbers over here are the numbers that we saw on our calculator, or very similar. They're slightly different only because we rounded. That's fine. Another way to think about this, and we're just going to have a look at payment number 1 here, is that if we make the first payment of this, we need to actually consider that if we're making this payment, we also have to consider that this $3,500 is going to have compounding interest on it. So the first thing that happens is $18.97 gets added to the $3,500, which means that this $711.42, all right, we have to subtract the $18.97. So we're really only paying off a true value of $692.45 off the actual loan amount. Okay, so in other words, there's $18.97 that the bank is making from that transaction. So that money goes directly to the bank, and this is how the banks make their money. This process is just constantly repeated until we get all the way down to our final answer. I'm not going to go through the second table. We're just going to get stuck straight into an example now. So let's have a look at example 9. Okay, the table is already written out here for you. Mimi takes out a loan of $1,500 at 9% per annum to buy a new computer. The loan is to be paid back monthly in equal installments of $382.06. The incomplete amortization table for this loan is below. All right, cool. So let's have a look at question A. What is the interest rate per payment period? Well, A. The interest rate per payment period, if it's 9% per annum, we just need to divide that number by 12. That's it. That's all we have to do there, which means the interest rate per period is 0.75%. That's it. That's how we answer A. So every month she pays 0.75% of the loan. B. How much of the second payment of $382.06 is interest? Okay, well, let's have a look at B. So the second payment is here. All right, so that's the second payment, and we are asked to find this value here for B. All right, so I'm just going to put a little B there. The easiest way to work this out is that if you already know the principal reduction and you know the payment, we're simply going to subtract those values. But you don't always know the principal reduction. Sometimes, and in fact in this case, we can think about this amount, $1,129.25. We can just multiply that by 0.75%, the answer that we got in question A, to figure out how much interest is going to compound on that. So I'm going to work out both ways here in B. We can go 382.06 minus 373.59, and we get the answer of $8.47. Alternatively, we can consider the original amount of the loan for this payment period, so that's 1129.25, and multiply that by the 0.75%, and we also get the answer, $8.47. So the answer for B is $8.47. All right, so let's highlight our answer for B there. For C, we want to know the balance of the loan after 2 payments have been made. Okie dokie. So for C, we're looking for what's going to go in this box here. All right, well, if we originally had this amount and now we've paid off this much of the principal reduction, that means we're simply going to subtract those values and figure out what the new balance of the loan is. So 1129.25 minus 373.59 will give me my new value or my new balance of $755.66. So let's pop that in our table. Part D, what is the principal reduction after 3 payments have been made? All right, so now we're looking for this space, D. The principal reduction is simply going to be this value minus that value, okay? Because $5.67 have to be paid to the bank, and the remainder of it will go here for part D. All right, so $382.06 minus $5.67, which means that $376.39 is actually reduced off the principal. E, almost there, guys. What is the total interest paid on this loan? What we're going to do in that case, and let me choose a different color highlighter, is we're just going to add up everything in this column here. Okay, so if we have a table, we need to use it. At capital I for the total interest paid, if we add up 11.25 plus 8.47, we get the total interest paid over the life of the loan is $28.23. That's not a lot of interest, but we don't expect it to be a lot of interest because he's only taking out $1,500 and he pays it back after 4 months. All right, so it's not a very big loan and not a very long loan either. And finally, our final part of the question is F. What should the amount of the final payment to ensure a balance of 0 at the end of the loan period? Well, guys, in this case, and I'm just going to go over here, F, rather than having an outstanding balance of 5 cents at the end of the loan, what we should do is rather than paying $382.06, we should pay $382.06 plus that 5 cents. So our final loan value should be $382.11. All right, and that's normal. Sometimes if you have just a really small amount left to pay on a loan, you just make that final payment a bit bigger. That's fine. It's nicer than having to deal with one more payment period of such a small amount. Now, guys, this is very tedious. There's a lot of work that goes into here. So make sure you take your time, ask me questions if you have them, and move on to exercise 8.2 and just work your way systematically through those questions. We can chat on Friday at our collaboration session to go through any questions that everyone is struggling with.